Alright guys, today we're going to be doing the corresponding parts of similar figures. It's very similar to the corresponding parts of congruent figures, but now we're going to start talking about similar figures. And we've made it to the halfway mark. That's 100 and 101. Okay, we actually won't make it all the way to 200, but we're going to go ahead and label 100 and 101, and then we're going to do the two foldables that are attached with this video. So let's turn to 100. Go ahead and label 100 as, I already forgot what it was, 11.3 corresponding parts of similar figures. So that's on 100, and 101 has the exact same title. Okay, so we'll get started on the foldables that go with this lesson. That's 101. We'll come back and glue those in right here in a little bit.
Alright, today we're going to talk about similar polygons and their corresponding figures, sides, angles, this kind of thing. So first of all, the key concept, two polygons are similar, since we're talking about similarity, if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. The symbol for similar is like a little tilde in Spanish there. It was like the congruent symbol, but it doesn't have the equal underneath. An example of that, if we have two triangles, they are the same shape, or should be, mine are not really, but they're just either a smaller or larger size, and they should, so all of their angles should be congruent. So since I'm making this example up, we're going to try to make one where it makes sense for them to be congruent. Let's say this is 80 and 80, and what is left over? 120, 70. That does not look right. That's okay. Okay. All right. Then we have a similarity statement. Let's name this first. A, B, C, D, E, F. So our similarity statement, we're going to look at the measures of our angles here. We go 80, ABC. ABC is similar. ABC is similar to DEF. Our corresponding angles, or congruent angles, are angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. The sides are proportional, so we write those as AB over DE should be equal to the proportion of BC over EF, which should be equal to the proportion of AC over DF. That's how we write the corresponding sides. Now, if you have just one or two, you also can mix them up. You don't have to have all three in there. But there is an example of two similar triangles. So we're going to look at example 1 to determine whether the pair of figures is actually similar, and we're going to justify our answer. So in this example, first of all, our angles should be congruent. So we already know that angle B is congruent to angle S because they're both 80 degrees. We need to find the missing angles, though, to make sure these are really similar triangles. So, let's see. We have 80 and we have 60, so we have 40 degrees left. 80, 40, there's 60 degrees left. These do come out congruent, so angle A is in fact congruent to angle R, and angle C is congruent to angle T. So we've got the first statement. It says two polygons are similar if and only if their corresponding angles are congruent. We have that piece, but next we need to make sure the measures of their corresponding sides are proportional. So we're going to compare AB to AB 60 to 80 to RS. We're going to see what that is. 5.2 over 3.9. And we're going to reduce that fraction so that we have either an improper fraction or a decimal. It doesn't matter as long as we get something that will be the same. So 5.2 and 3.9. I get 4/3. If this is the same for all the sides, I do have similar figures. We've got to keep looking. BC over ST. 7 over 5.25. 7 divided by 5.25 is 4/3. That one works out. We need to check the last segment. I'm going to have to do that one over here. AC over RT is 8 over 6. So like this one, it's easy to figure out. That is also 4/3. Since all of these are proportional and the angles are all congruent, we know that ABC is similar to RST. That is how we determine if something is similar, by looking at the angles and by looking at the sides. You have to make sure the angles are congruent, the sides are proportional. Your work justifies your answer. Something that we just figured out is actually called the scale factor. So the scale factor is a numerical proportion or a numerical ratio when comparing the lengths of corresponding sides. So since the figure we just had is in fact similar, its scale factor would have been 4/3. So let's look at another example kind of like that. So example 2 says the two polygons are already similar. So we already know they're similar. And it says write a similarity statement. So we're going to look based on the marks of the angles. So A's got a 1 mark and R's got a 1 mark. So A and R would go together. But A, so 1, then 2, 3, 4, 5. So we're going to go in the order that is presented there. Similar symbol. And then R is 1, 2, 3, 4, 5. So we're going to go R, S, T, U, V. Since we don't have, it's not a triangle or something, we're not going to put anything there. It's just polygon A, B, C, D, E, or pentagon A, B, C, D, E. Okay. We need to find X, Y, and UV. We are going to have to set up a proportion to do so. We also eventually are going to need to find the scale factor, which we can do here as well. Notice it says find the scale factor, which is going to help us, of ABCD to RSTUV. That means we're going from the larger one to the smaller one. Larger to smaller means we are going to have a number bigger than 1. So the larger number, let's look at this side specifically, 6 over the smaller number, I said that backwards, we are going to go from larger to smaller, which means we should have a number that is less than 1, not larger than 1. We always are going to take, we talked about this not too long ago, we have the image, we have the pre-image. That's how we're going to set up our fraction, is image 4 over pre-image 6. And that reduces to 2/3. Therefore, that is our scale factor. We are then going to go back up and do letter B. Having a scale factor is going to help us do that. 3 is in the image. So we're going to make a fraction to find x with the image value 3 over 3 and x are corresponding. X is from the pre-image. This should be equal to the scale factor, 2/3. We are then going to cross multiply. We are going to get 2x equals 9. Divide by 2, x equals 4.5. That is one of our answers. Not going to write it there, we don't really have the room for that. Next, we need to find y. Here is y. It is in the image, so it's going to go on top of the fraction. Y plus 1 over the pre-image 8. Again, that should be equal to the scale factor of 2/3. Likewise, we are going to cross multiply. So we have 3 parentheses y plus 1 equals 16. I can either distribute this 3 or divide 16 by 3. I'm going to distribute, but it really does not matter what order you do it in. That equals 16. I'm going to subtract 3. 3y equals 13. I'm going to divide by 3. Y equals 13 divided by 3. I'm going to leave it as a improper fraction for now. 13 over 3. That's the next part of the answer. Now, it also says find uv, which I'm just going to do by plugging in. So I'm going to add 1 to y. So uv, I'm going to write it up here because I'm out of room, is 16 over 3. So x, y, uv. Not numbered. The next question is very similar. It's a good idea to pause the video, try that one for yourself. It's kind of already set up for you a little bit, so I would do that. Pause it, try it for a second. Right, in this example, we're supposed to find FG. FG is corresponding to BC. So they have BC over FG. Then you have to look at what you already know. You know the length of AB, you know the length of EF, so you put this in a proportion. They then plugged in. Now we're going to cross multiply. So 20 times x equals whatever 16 times 12 is. 192. Then we're going to divide by 20. FG is 9.6. Check, make sure you got the right answer. Example 3 is the same. You were supposed to find the length of RS. Again, good idea to stop it. Try it yourself. Again, we can set up a proportion. We already know what NP is. We already know what QS is. It should be equal to OP over, we've got RS. Notice NP and OP on the top are from this triangle. QS and RS are from this triangle. It doesn't matter if you swap them as long as you have one triangle on the top, one triangle on the bottom. We're now going to plug them in. So 8 over 17 should be equal to 24 over x. We don't know what RS is. Like we did a minute ago, cross multiply. AX equals whatever 17 times 24 is. 408. And then we're going to divide by 8. That is 51. RS is 17. Just copying down QS is 51 inches. These questions can also be done with example 4 and 5. These are word problems. This is actually called indirect measurement. This gets used when you don't nobody really needs to or has to climb a tree or anything. You, based on the shadow, the sun rays come down at a parallel. They come down parallel, so you will have this is a right angle here, and this is a congruent angle because they're corresponding. They come down in parallel lines. So we have two similar triangles. Based on that, we can read this. We can figure out how tall this tree is by indirect measuring. It's the same process what we just did. We're just going to have to fill out what we know. Okay, so a tree casts a shadow that is 10 feet long. Here's the tree shadow, it's 10 feet. A woman is 5 feet tall. She casts a shadow that is 4 feet long. Here are the similar triangles. We have to find how tall the tree is. We're doing the same process. 4 over 10 equal to 5 over what we don't know. So 4x equals 50. Divide by 4. X equals 12.5 feet. We need to make sure that makes sense. Obviously, it needs to be taller than the lady. The 5 was taller than the 4, so our 12.5 is taller than 10 feet. So we're fine. We've done that correctly. Take a minute to look at example 5. Try that one out. Same process. Alright, a 6-foot tall man casts a 4.5-foot shadow. A telephone pole casts a 15.6-foot shadow. Two similar triangles are created. We can't do this if they're not similar triangles. How tall is the telephone pole? Exact same process. 4.5 over 15.6 equals 6 over x. It might help you know that's x in case you're curious. So 4.5x equals 15.6 times 6, which is 93.6. Then divide by 4.5, which is 20.8. So the telephone pole is 20.8 feet. There is a good way of how to use similar triangles to solve problems.
All right, now that we're finished with these, we're going to go ahead and glue them in. So on page 100, we're going to put the just the half sheet of paper. I'm going to glue that in on 100. I like writing on them before I glue them in. Especially on the left side, it starts to get really hard to write on those. All right, so glue that one in there. And then we will glue the other one, the one that opened up, the foldable, on 101. Okay, so the one that opens goes on 101. And again, if you need some help, you need to ask. We will we'll have an assignment posted for this lesson. And we'll do a new lesson tomorrow. But there you go. Go ahead and get started on the assignment that's posted on Google Classroom now.